Okay, moving on. The next type of next type of equation that could be on your test, and I'm not going to go in the same order, could be one like this. Wow, what a beast. Now, the first thing I want you to notice about this equation is we have third powers, fourth powers, second powers, all that kind of stuff, okay? I did not. I'm glad you mentioned that to me. I'll tell you why. Just ignore this -3. I'll tell you why it's there in a second. All right. Now, what we did is we called this in your notes finding zeros, and we did this earlier on the graphing part. All we do is we just use synthetic division and test numbers till you get out a problem or till you get out a number, and then continue on. On the test, I will actually give you one of the zeros to get you started again, so it's not that hard, okay? Now, I know you men, Matthew, you included there, I know you guys are copying this down, okay? I'm going to go ahead and bring all of these terms right here to the other side so we have one side equal to 0. So that's the first thing we're going to do. And I'm going to go ahead and combine like terms. Your x to the fourths will cancel out. Okay, this is not right, by the way, guys. Something's wrong with this. So I'm going to pause the video and get out my worksheet because there should be a whole number somewhere that I've left off here. So hold on one second. Okay, Matthew, I paused the video. This problem here, the original problem, and I apologize, really should have a positive 60 squeezed in right here after the 7x squared and before the equal sign. So so there we go. So Chase, Michael, sorry about that, but now when you bring over the 12x squared and make it negative, bring over the 2x squared and make it negative, bring over the negative 4x to the fourth and make it positive, you should be left with this right here. Okay? And I will give you one of the answers to this. I'm actually going to get you started, okay? So I'm going to say to you, solve this, and I'm going to go ahead and tell you that one of the answers in this case, what did I have up here before, 3 or a -3? I forget. -3. Let's check and see. Yeah, you're right. So on the test, I would say one of your answers is -3. Finish this and, solve this. So -3, use synthetic division, and you would be left with 1, 5, -12, 60. Bring down your 1. So -3, 2. That can't be right. Boy, I'm hitting a home run today on my mistakes, aren't I, guys? Oh well, I did plan. It should be a -60, not a positive 60, I believe, is one problem. So make that 60 negative. Sorry, guys. I mean, I'm totally prepared. I'm just not concentrating. Make that a -2. That's a -6. Okay, guys, welcome to the Erhart Academy of Mistakes. The 0 is a +5, I believe. Let's try that. So sorry about that. So you get to wear out your erasers today. And if this doesn't work, we're just going to quit. All right, so let's try this again. So a +5 should be one of your zeros. So we'd have a 1 here, a 5 here, a -12 here, and a -60 here. Now, I hope this works. If it doesn't, we're going to be a little frustrated. Okay, let's go over synthetic division too while we're doing this. What you do is you always bring down the first number, so that's easy, bring it down. Then you multiply. You multiply and then you combine over and over and over. So 5 times 1 is 5. And actually, I'm thinking that one of the zeros is a -5. So actually, this here is a -5. And again, we're just going to be really, really consistent and mess this entire problem up. And yes, I'm embarrassed, but that's just life. So we all make mistakes. And again, it's all organized here. I'm just not looking. But I have written right here a -5. So, okay. So one of the answers is a -5. So you bring your 1 down. And then you multiply, that's a -5. Then you combine, that's a 0. Then, Chase, we multiply again. So -5 times 0 is 0, okay? Then we combine again. Negative 12 plus 0 is negative 12. Then we multiply again. Negative 5 times negative 12 is positive 60. And we do get out a 0. All right? So we know one answer is negative 5 because I gave that to you after about 3 or 4 bad tries, okay? So we know one answer is negative 5. Now be careful here. Michael, Chase, Matthew, what is my degree of my equation right here? What's my highest exponent? 3? So you go 1 less than that, right? So it would be 1x squared. And you really don't need to put the 0x unless you want to, okay? So it would be 1x squared plus 0x, but you don't have to put that, minus 12. All right? So we know so far, we know one answer is negative 5. So I'm going to go ahead and put x equals negative 5. And I'm left over with x squared, was it minus 12 or plus 12? Minus 12. And now we have all of that left over. Now we know how to solve that, man. Bring the 12 over and make it a positive 12. And take the square root of both sides. Plus, minus, that'd be 3 point something. I'm just going to guess. Let's see, 9, 16, about 3.4. I'm estimating that, 3.4. So there's your answers. X equals negative 5 and 3.4 and negative 3.4. There's your 3 answers right there. That was really poorly taught. Let's not beat around the bush about that, and I apologize, but that is how you do it. So let's review. Since I just did a poor job on this, let's review. I'm going to give you a problem like this. And you're going to get one side equal to 0. Okay? After you get one side equal to 0, like we did here, I will give you one of the zeros to help you, okay, to get you started, or one of the answers. So I told you, after many tries, I told you negative 5 was a 0, and it was. And so then we were left over with this right here. And so then we take our leftover and we set it equal to 0 and we solve. So the one on the test will be pretty similar to that. Okay? All right, let's continue on to the next problem. On page 47, you will see how to solve square root equations. On page 47, you will see how to solve square root equations. On page 47, you will see how to solve square root equations. So here we go. Your steps are on that page in your notes. After January 17th, page 47. Okay, the first thing you want to do is get the radical all by itself. So you want to subtract 7 from both sides. Or move the 7 over and make it negative. When you do that, you will get this right here. Everybody good with that? Now on the test, I cannot promise you I will give you a square root. It might be a cubed root, or a fourth root, or a fifth root. So it depends on what your index. In this case, we have a square root. Even though there's no 2 there, it's a square root. And how do you get rid of a square root? Someone tell me, please.
Doing what you're doing there.
Squaring it?
Yeah.
Okay, but if you square one side, you got to square the other side. So now, Chase, I have a question for you. If this would have been a cubed root, then you're good, excellent. Okay, so Matthew, if this would have been a cube root, we cube it. It's a square root, so we square it. Whenever you square a square root, you get what's on the inside, which is 2x minus 3. If you square negative 3, you get 9. And now look what we got left over, the simple linear equation. Add 3 to both sides, and you get 2x equals 12. Divide by 2, and x equals 6. And that's not your answer. This is your answer right here. And I picked this problem on purpose. Men, square root, cube root, radical equations are the ones you have to check your answer. And even though you get an answer out, sometimes it doesn't always work. If you come up here and put a 6 in to this radical, do it real quick. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3, and 3 plus 7 is 10. Look what you get out if you check this answer. Look right here, guys. You get out 10 equals 4. That's not true. If you put a 6, I'm doing a video, Luke. If you do a 6, if you put a 6 in for x, you get 10 equals 4. That doesn't work, so the answer is no solution. So please don't forget to check those on the test, okay? All right, moving on. Next problem. All right, now we're looking at this type. It's also page 47 in your notes. And these are called rational exponent equations. Rational exponent equations. Okay, so if you'll look at page 47, the first thing you'll see is you want to do this right here. You'll see this. X to the 2/3 means this. That's the first thing you want to do. I hope you remember that. A fractional exponent can be rewritten like this. The bottom of the fraction is your index, and the top of your fraction is your power of the radicand on the inside. Now we just have a square root equation to solve. So let's add 6 to both sides. So now we have the cubed root of x squared equals 18. Cool, that's easy. We can do that, can we not? Now, we have a cubed root, correct? So we raise it to the what power? Third power. And a cubed root raised to a third power, your 3's would cancel out. Your radical is gone. You're left with x squared equals, help me out, 18 times 18 times 18. I'm going to do that in my head, Matthew, just to impress you. 18 times 18 times 18 would be 5,832. Don't you dare think that I used a calculator. All right, 5,832. Now, is x by itself, Chase? Okay, so now I've got to take the what. It's an x squared, Mike. Take the what of both sides. Square root? Are you trying to be like really cool and quiet today or what? You're being really quiet. All right, x squared equals 5,832. Now, take the square root of both sides. And you don't forget your plus minus. What do you get, Mike? 76.4. There we go. He rounded that, so that's not exact, but there you go. Pretty cool, guys. Not that bad. But you know what the problem is I'm going to mix all of these equations together. So Matthew, Chase, Mike, when you study for this test, step 1 is to get all the graphing problems together on a sheet of paper, whether you got to rewrite them. I mean, it's going to take work. It's supposed to. It's Algebra 2 for crying out loud. And you're going to have to look at each one and say to yourself, and go through each one. Same thing with your equations. You're going to have to look at each one and recognize it, because if you can't recognize it, you're going to have a hard time solving it. Is it fun? It ain't more fun than hanging drywall or digging footers for a porch, but it's life, guys. I mean, it has to be done, okay? And that's just how it is. So, all right, moving on. Do you have a question, Mike? Okay, next problem. Oh, now here's where we say the rubber meets the road. Now we're getting into exponential equations. If you'll look on page 68, you'll see some steps. Page 68, if you want to write that down. Page 68. All right, now watch carefully what I do. Please, men, watch carefully. Here's my unknown. I'm going to circle it for you. X minus 2. What is the base of x minus 2? Can anybody tell me? What's the base of x minus 2? Is it 12? Is it 19? Is it 3? Is it 7? What's the base of x minus 2? So that's what you want to get all by itself. I'm circling it for you. Do you see that whole group, guys? You want to get that whole group all by itself, 7 to the x minus 2. So the first thing you do is you subtract 12 from both sides. So 3, 7, x minus 2 power equals 7. Because I subtracted 12 from both sides. Got it? Subtracted 12 from both sides. Now, Chase, what is the 3 doing to the 7? Adding, subtracting. Okay, so I divide both sides by 3 to get rid of that 3, because the opposite of multiply is divide. So divide by 3, and now I'm left with 7 to the x minus 2 equals 7/3. Everybody with me so far on this? It's not too bad. Now, Chase, we went over your test. Remember on your test, you knew exactly what to do. You knew that because you had a base 7, you would take log base 7. But what you didn't do on your test, remember, is you forgot to get this all by itself first. So, but now you're seeing. So get the base and its exponent all by itself like we did right here. Now, what is the base of the unknown? 7. So we take log base what of both sides? We take log base 7. Now, Matthew, you're not here to ask questions. Listen, see this 7 right here? If this 7 would have been a 9, then we would take log base 9 of both sides. If this base would have been a 19, then we would take log base 19 of both sides. Okay, but it's not. It's a 7, and that's why we use a 7. Now, log base 7 of this whole side. So bring the whole side down. 7x minus 2. Log base 7 of this whole side. So bring down your 7/3. You all with me on this? Now, here's why we did that. Whenever a base matches a base, and Chase, you know this well, they cancel out, and you're just left with x minus 2 equals log base 7 of 7/3. Now, you know what I would do? I think some of you guys want to add 2 to both sides, don't you, to get x by itself? I wouldn't do that yet. I really wouldn't. I would type this into your calculator first to get a decimal. I really would. Remember how to do it? You would type in log of 7/3, close your parentheses, over the log of what? 7? Everybody with me on that? Okay. Matthew, I'm going to type that in real quick, so just be patient, please. Log of 7/3 divided by log of 7. Okay, you get 0.4354. Now, that's not your answer. That's just the right side. 0.4354. Over here, we still have x minus 2. Now, Michael or Chase, what would you do now to finish the problem? Just one step left. Move the 2 and make it positive. So, Matthew, we're going to add 2 to both sides. Your answer is 2.4354. Now, you might have rounded somewhere else. I really don't care a whole lot about that. I'm just saying that's how you do it. Okay? All right, moving on. We're doing really well. I know earlier in the class period you are like, are we going to finish? I really thought we would because the last ones are decently simple. Okay, now look at this. Guys, here's another exponential equation. Do you guys not see the difference between this one and the other one? Look at the one we just did. Here's the one we just did. We had an unknown on one side. Did we have an unknown on the other side over here? But look at this one. This one has an unknown here and an unknown here. So it's done a little differently. And actually, these are a little easier in my opinion. All right. Now, if you'll turn to page 68, Matthew, page 68 is where you'll find the steps for this type of a problem. And on page 68, what you would see is I have both of these two different types listed out. The type like this where you have one unknown on one side, and the type like this where you have unknowns on both sides. Okay. So here's what we're going to do. We're going to have to write both sides with the same base. Now, right now, I have a base of 8 and a base of 32. How could I write both of those sides so that they have the same base? What number would I use? I don't think I can because I'd have... Yeah, but look, remember, it's 8 to the 4th power, not 8 times 4. Yeah, and that would be like thousands, so... I think we're going to have to change both of these to a number. How can I rewrite a 2 with a what base? What do you think, guys? What times what times what times what times what times what times what would give you 8? Okay. So for 8, I'm going to put 2 to the what power? So Matthew, you're listening. 2 times 2 times 2. 2 to the 3rd power is the exact same thing as 8. So for 8, I substitute 2 to the 3rd power. Do you see that okay, guys? And then over here for 32, this is really cool. 2 to the 5th power. If you'll take your calculator and test, you'll see that 2 times 2 times 2 times 2 times 2 is 32. Now, remember Chase on your test? When you multiply 3, it goes to both of them. 3 times 3x and 3 times negative 2. So now I have 2 to the 9x minus 6. And over here, Matthew, I would have 2 to the 5x minus 5. Does everybody see where these numbers are coming from? And now, men, when your bases are the same, you're more than welcome to cross them off. I don't know why I put that 2 right there. Let me back this up and change that. That's really doesn't make any sense at all why I did that. 5x minus 5. There. Now, when your bases are the same, just simply cross them off, and you're left with 9x minus 6 equals 5x minus 5. Now, you should be able to finish that on your own. It's not too hard. If you bring the 5x over and make it negative, you're left with 4x. If you bring the 6 over and make it positive, you're left with 1. Does that make sense? 4x equals 1. If you're lost, please tell me. 4x equals 1. And then divide by 4. Your answer would be 1/4 or 0.25 if you prefer. That's up to you. We're doing great, guys. 15 minutes for 2 more. Actually, I just finished a couple minutes early, to be honest with you. Although I wouldn't hold your breath on that, but it could happen. It is slow. That's true. Okay, here we go. I'm gonna put 2 problems up here real quick. Notice how here's a logarithmic with 1 logarithm. Look at the last equation we're gonna do. 2 logarithms.
That's it?
Yeah. So make sure you're really, really sure of what to do here. Okay. One of them, I think. I think you got one right and missed the other. I think. Okay. All right. Well, here we go. Page 69 for both of these would definitely be the page you would want to turn to. All right, now, notice we have 1 logarithm on one side. What did I just say? Yeah, 69, yep. Okay, we have 1 logarithm on one side. So you want to get this logarithm right here all by itself. So you add 10 to both sides. So log base 3 of x plus 4 equals 24. 24. And now that you've done that, men, it's really pretty easy. I mean, it's really pretty easy. You write it exponentially. So x plus 4 equals 3 to the 24th power. Now, I don't know why I did that. I don't like that, okay? It's going to give you some huge scientific notation problem. So, I just didn't mean to. Type what is 3 to the 24th. How bad will that be? Yeah, it's scientific notation. Chase, Matthew, Mike, change this 14 right here to a... just take a second, guys. Don't get all worried about it. Change it to a... Change that 14 to a -8, please. A -8. Change that 14 to a -8. Sorry about that, guys. And then when you bring the 10 over and make it positive, you'll have a 2 right here instead of a 24. So make your 24 a 2. And then you would just have 3 to the 2nd power.
Why are you putting 3 to the 2nd power?
I will show you. I will answer that in a second. Let me. Because you're writing it, you go from logarithmic form to exponential, so you bring this 3 over and push that 2 up, becomes 3 squared. Remember our, okay, remember this? Log A, come on, my pen's not working. Log AB equals C, cab equal B equals A to the C. That's what we're doing. Logarithmic form to exponential right there. And then we simply, well, we know that 3 squared is 9, so we really have x plus 4 equals 9. And then subtract 4, x equals 5. Now you do want to check these. Please don't forget that, guys. I'm going to make a side note of that. Your argument can never be negative. Let me say that again. Your argument can never be negative. And what is your argument in the original problem? X plus 4. What does x equal? 5. Put a 5 right in for x. Put a 5 right in for x right here. What's 5 plus 4? 9. Is 9 positive or is 9 negative? Well, it's positive, so you're good. You don't have to check the whole thing. Just make sure your argument is positive. Okay, moving on to number 28, and man, we are done. So how exciting is this? Page 69 again. Now, notice we have 1 logarithm on one side. 1 logarithm on one side. Do you see that okay? I'm sorry, you have two logarithms on one side, two on one side. So here's what we have to do. Remember how you learned condensing and expanding properties? We've learned how to put two logarithms together when they have the same base. Please watch what I do. The first thing you want to do is take the 2 that is out front, and you want to write that as an exponent of your argument. So this 2 right here, see this 2 right here, guys? I moved it as an exponent right there, all right? All right, now next, here's what I've taught you. Whenever two logarithms are being added, you can multiply their arguments. So you really have log base 4 of what? 6x squared. Let me go over that again. And Matthew, in case you're watching this a little confused, whenever you're adding two logarithms that have the same base, you can write the log how many times? Once, as long as you do what to the arguments? Multiply them. Does that ring a bell a little bit? I hope it does. I'm not asking you to teach the class, but it should ring a bell, okay? And now, can we go back to the last problem, please? Mike, here's where you were confused. When we had one logarithm on one side, we wrote it exponentially, right? So can we not do the same thing here, guys? We have one logarithm on one side, so write it exponentially. 6x squared equals what? 4 to the 5th power. Do you see that okay? 6x squared equals 4 to the 5th power. Should be 320. Is that right? I did that in my head.
1024.
Or 1024. All right. So Matthew, hopefully you're good with this so far. 6x squared equals what, Mike? 1024? All right. Now you should know what to do, guys. Come on. Divide by what? 6? Divide by 6, and you would get 7. I'm getting 170.6 repeating. Can you confirm that? Okay. And then take the square root of both sides. Guys, I don't know what that would be, but plus minus 13, 14 times 14. It could be 14 point something. Someone type that in when they get a chance, please. The square root of 170.6. Repeating. Are you sure?
13.06.
Now hold it. Matthew, you're listening to this hopefully. I put a plus minus in front of it, but remember how you got to check your answer? I'm telling you, they might not both work. Let's go back to your original. Ooh, look at this. Look, guys, here's your original problem. My two answers are positive 13.06. Well, that works. If I put a positive 13.06, I have a positive argument. But look, if I put a negative 13.06 right here for x, Matthew, do you see if I put that in for x, I've got a negative argument. I'm taking the logarithm of a what number? Negative number. Can you do? Right, you can't do that, so you do not use the negative sign. You would lose points on the test if you did. Your answer is only positive 13.06. Wow, what a marathon. Well, Matthew, you really missed out. We had pizza, cake, ice cream, subs. We had a whole bunch of stuff here you missed out on. I'm kidding. That's it. Study for the exam. Let me give some announcements here, Chase. You need to hear, and Matthew, you can hear this too, okay? Your exam is Thursday. Study your tail end off. When you come into class, if you have a bunch of questions and you don't start your test on time, this is how I've been all year. I don't care. It hurts you, okay? Because you're going to end up taking most of the test home and working on it without me there to ask you questions. Then you're going to have to correspond and email me or call me, which I don't care, but I just think that would not be a good decision. So make sure you're really ready for the test so you can apply all 2 hours to your test. All right? Call or email if you have any questions.